Okay, year 13. Here is an example of a definite integral that involves integrating a trig product. It's quite daunting, but it's good exercise in keeping a sharp eye out for sign changes, etc., etc. All right, how does it go? Well, we're being asked to integrate between 0 and pi over 2 this product here. Sine 3 theta is multiplying cos theta, d theta. Well, you can't integrate a thing like that unless you break it up. And you break it up using this trigonometric identity here. When you're multiplying sine with cosine, then you can write it like that. Okay? Now, this is the sine of the sum of the angles, whatever A and B are, plus the sine of the difference between the two angles, whatever A and B are. Okay? Be very careful with this 2 that's multiplying this part of the trig identity, because if you just write sine A cos B equals, then really you can cross multiply this 2, and it's all of this multiplied by a half or divided by 2. So what I've gone and done here is I've done that there. I've rewritten this using this idea, but I've had to pre-multiply it all by this 1/2 there. Okay? All right, so how does it go? Well, this is the sum of the angles. So we're going to be doing the sine of 3 theta plus theta. There it is, 3 theta plus theta. Plus, now you must make sure that that's a plus sign. There it is there, plus. Plus the sine of the difference between the angles, between 3 theta and 3 and theta. So we're taking them away. So this now reduces to something a bit simpler looking. We can now take this half outside the integral sign, there it is, okay, and we can now write the integral between 0 and pi over 2 of sine 4 theta plus sine 2 theta, d theta. Now, because we've split this up into the sum of two separate trig functions, we can now integrate them separately. And that's exactly what we do. Okay? So what we do is we now integrate separately. Now, when you do these sorts of things, you must be super careful about this thing here, which is actually multiplying everything inside that integration. So if you're going to now integrate this and then integrate that, as you should, you must use some sort of squiggly brackets, or sometimes they use a square brackets there. But that square brackets closes over here because everything is enclosed inside here. Everything in here is being multiplied by that half. All right, we can keep that stuck out there and concentrate our attention to integrating each one of these separately. Okay, so first thing we realize that we've got to replace this 4 theta by another variable in order to make it accessible to integration. So we do our little tricks. Let u equal 4 theta, so du is 4 d theta. Now here, when I do this thing, I can't let it equal u because I've already used the symbol u, or the variable u. So I'm going to let it be called v. Okay? So I'm going to let v equal 2 theta. So dv by d theta is 2, so dv is 2 d theta. Here, du is 4 d theta. Now we pre-multiply the d theta here by 4, dividing by 4 at the same time. Here I'm pre-multiplying the d theta by 2, but I am dividing by 2 at the same time, because that integral's got to stay the same value. this integral's got to stay the same value. All right, so this 4, which is dividing the integral now, can be brought forward in front of the integral sign there, just as this 2 can be brought forward in front of this integral sign there. So your next line should look something like that. The 4d theta is du, the 4 theta is u, the 2 theta is v, and the 2d theta is dv. Now, of course, you've changed the variables into u. So here, you can't use 0 and pi over 2 because they refer only to theta. Okay, so you've got to write u1 and u2, v1 and v2 there. Okay? All right, so now you can see how we have reduced everything to two very simple looking integrations. Okay, so clearly this is the derivative of cos u, and that is the derivative of cos v. So that's what the next line looks like. Okay, now I haven't written cos u and cos v because I've put it back into the theta form because it's cos u and the u is 4 theta, so I've written 4 theta. Okay, and again, I've written, instead of the v, I've written cos 2 theta, which is cos v, when you integrate this sine v. Nonetheless, each one of these, you now put the proper limits back in, 0 and pi over 2, 0 and pi over 2, and now you work out, you substitute these limits into instead of theta there, this limit instead of theta there, and so on with the 0 limit down there as well. So your next line will look like the following. You've still got your half out here, you've got your squiggly brackets. Now that quarter is now going to multiply everything you have inside this brackets when you substitute in this limit here. So you're going to be saying the cos of 4 pi over 2, and don't forget all of that is an angle, minus the cosine of 4, substituting in this limit for the theta there. And if you do the same over here, you'll be writing that this half, you must have the brackets because this half is multiplying everything inside the brackets, just as this quarter is multiplying everything inside that brackets. So now you put in pi over 2 for theta there, and there it is there, minus the cosine of 0, which is putting in that thing into there. Now, I haven't written 2 times 0 because 2 times 0 is 0. Okay? I've written 2 times the pi over 2 there to make it clear, but I didn't write the 2 times the 0 there. Doesn't make any difference. Now, this is where things get a little bit tricky because you've now got to understand why some of these values give us the values they do down here. As I said, I could explain it in a long explanation using the unit circle and or the graph of cosine, but if you want the short explanation, you just put these values into your calculator and you'll see. This 2 divides into that 4, so you're really finding the cosine of 2 pi. Now the cosine of 2 pi is really positive 1. This 4 multiplies 0, so that's really the cosine of 0. Now the cosine of 0 is exactly the same as the cosine of 2 pi. That's also 1. Well, what have we got left? We've got 1 minus 1. Well, that is a 0. This whole brackets goes to 0. And 0 times a quarter is 0. Okay? Now, let's do this one here. This 2 beneath the pi cancels with this 2 here. So it's really finding the cosine of pi. Well, finding the cosine of pi gives you minus 1. minus the cosine of 0. Well, the cosine of 0 is plus 1. But this plus and this minus are going to go to minus. So your next line will look like this. Okay? You've got, let's do this one here. So we've got 1 minus 1 is 0. 0 times a quarter is 0. So all of that just vanishes to 0. This one doesn't. You've got minus 1 minus 1. So you've really got minus 2. Minus 2 times a half is minus 1. Okay? And minus 1, when you multiply in this half here, this half goes to minus 1 times a half, goes to minus a half. That is your final answer. Now, I have looked at the answer in the back of the book, and they give the answer as plus a half. But I've checked it and I've double checked it, and I can't find where I've gone wrong. So I open a challenge for anybody who would like to go through this analysis that I've done here and see if they can find out where I have gone wrong. So there you go. There's a Kit Kat in it for anybody who can find out why I get minus a half, whereas the book gets positive a half. It's not to say that the book can't be wrong, but it's more likely that I'm wrong than the book. But that is the way you would do a question like this. It is pretty tricky. You've got to keep a sharp eye out for sign changes, which I think I've done properly, and my answer comes out minus a half. All right. Thank you very much.